Hello everyone, welcome back to Geeks for Geeks. So today we are discussing about the weekly coding contest and here we have the first problem. So the first problem name is distribute balls. So let's have a look on the problem statement. So the problem says that Geek has two bags and there are n di distinct balls. Okay, he has to distribute these balls in those two bags such that each bag contains at least one ball. Okay, so basically we are given that we have to distribute these n balls into two bags such that each bag at least contain one ball. Okay, find the number of ways in which he can distribute the balls. Okay, so we have to find the number of ways in which geek can distribute the balls. As the number of ways can be large, so we have to return the answer modulo 1e9 plus 7. Okay, so let's jump to the example test cases for more clarity about the problem. So in this example number 1, so we are given n is equals to 3. It means that I will be having 3 balls. So here I have 3 balls, that is A and then B and then C, right? So they will be distinct balls, right? So I will have one bag and the second bag as bag two. So like how can we distribute in such a way that at least one ball is there in uh, bag one or bag two? So the first distribution can be like I can put ball A in my bag one and I can put the remaining balls in my bag two. So B and C, I will put B and C in bag two. What can be the second case? So the second case can be I will only put B ball in bag one and the remaining ball in bag two. So A and C are the remaining ball. Now C in my bag one and remaining balls, that is A and B in bag two. Similarly, I can do this thing again with bag one. Like I can put ball A in my bag 2 and the remaining balls in my bag 1. So remaining balls are B comma C. So I am putting B comma C in my bag 1. And I can put ball B in my bag 2 and the remaining balls in bag 1. So remainings are 3 A comma C. And I can put ball C in my bag 2 and the remaining balls that are A and B. So here I can distribute these three balls in such a way that at least one ball is present in bag 1 and bag 2, right? So what are the total number of ways? So we can see that the total number of ways are 6. So here 6 will be my answer and output is also given as 6 and explanation is similar that we will be having three distinct balls ABC and bag 1 can contain ABC. So we have discussed this thing. Now let's move to the solution part, how we can proceed with the solution. Okay. Okay, so basically, for every ball, we will have two choices. So, what will be the first choice? So, the first choice is that I can put that ball into my bag one, and the second choice is that I can put that ball in my bag two. So, for every ball, I will have two choices. And let's see for three number of balls. So, for ball A, I have two choices. So, that's why I have written two here. And for ball B, I have again two choices. So, uh, I have written two here, and for C ball, I also have three choices, right? Sorry, two choices. So that's why I have written two, two, two. And how to find the total number of ways in such a way that I can distribute these balls. So I will be multiplying these. So multiply two, multiply two, multiply two. So it will be around 2 to the power 3, right? Okay, so that's how I will get the total number of ways in such a way that I can put ball A, B, C in these two bags that are bag 1 and bag 2. So this is my bag 1 and this is my bag 2, right? So it will come out to be 8. But here we have to keep the check of one thing, that is that we will have to keep at least one ball in bag 1 and at least one ball in my bag 2, right? Because it is given in the question itself that I can put at least one ball. I have to put at least one ball in my bags, right? So how to ignore or subtract those two cases? So these are my two cases. So subtract 2 from our answer. So why we have to subtract? So the first scenario is that all the balls ABC comes in bag B1, right? So the first scenario is that all the balls comes in my bag B1 and my bag B2 becomes empty. So is it a valid case? No, because it is given in the question that we have to keep at least one ball in my one bag, right? So that's why this is the case number one, which is invalid. And what is the second scenario? So the second scenario is similar, but in this scenario, my bag two can my bag two will be filled, and my bag one can become empty, right? So all balls ABC can come in my bag B2, and the remaining balls. So there is no remaining ball. That's why my bag one B1 will become empty. So that's why I have to subtract for this also. So basically, so what are the total number of ways we had? So we had total number of ways as 8, and we just have to subtract 2 from the total number of ways. Why we are subtracting? Because of these two scenarios, right? So the total answer will be 6. So answer will be 6 for n is equals to 3, right? So this was the solution, and let's discuss about the coding, how we can code this up. So we will be taking one modulo variable. So why we are taking this modulo variable? Because it is given in the question that we have to return the answer modulo 1e9 plus 7, and we will be also taking one answer variable which will be initialized by 1, right? After that, we have to find out 2 to the power n, right? Because if there are n balls and for every ball I have two choices, that's why 2 to the power n. And we have discussed earlier also how we are finding the total number of ways, right? So how we can find out 2 to the power n? So the first thing is that I can just use some inbuilt function, power function, but this power function will not be taking modulo because they are inbuilt and does not take any modulo. So we have to implement our own power functions. So basically it is very simple. We will just iterate n times, and we will be using my for loop, and inside that for loop I will just multiply that value at every time by 2. So that's how we will get the 2 to the power n. And in the end, just simply subtract 2. Also, take care of the modulo at every step, right? So we will be taking care of the modulo at every step. So we will be running a for loop, and for loop will be from 0 to n. And inside this for loop, I will be multiplying this answer. So what is this answer variable? So answer variable will be storing the answer. Okay, so answer is equals to answer into 2. Also take the modulo here, because at each step I have to take the modulo. So taking modulo, and in the end what I have to do, I have to subtract those two cases, right, that were invalid. Okay, so in the end, just do answer is equals to answer. Why we are subtracting here? So we have discussed that we have to subtract those two invalid cases, and for modulo, I am adding modulo in my answer, answer minus 2 plus modulo, and in the end, just simply return my answer variable. What is this answer variable? It is the answer for this particular question. Okay, let's see how we can code this up. Okay. So basically we are having one modulo variable which is initialized at 1e9 plus 7, and we are also having one answer variable which is initialized as 1. After that we are running a for loop. So for loop from 0 to n, and do I plus plus, and inside this for loop I am just doing answer is equals to answer into 2. Also, we have to take care of the modulo at each step. So just do mod, and in the end, just answer is equals to answer minus 2 plus mod, and just do the mod of this whole answer, and in the end, just return answer variable, right? So let's try to compile and run. Okay, so it's getting passed on the visible test cases. Now let's try to submit. Okay, so it's getting passed on all the test cases, right? So we will be discussing about the time complexity. So we can see that we are iterating n times, right? And inside this for loop, we have some constant we have some constants operation. So that's why our time complexity here would be big of n, because we are iterating n times. And talking about the space complexity, so as we can see that we are not using some extra space, so the space complexity would be constant, that is big of 1. Okay, now let's move to the second problem. Okay, so the second problem name is longest non-decreasing subarray. Let's try to read the problem statement. So you have been given an array ARR of length n. Your task is to find uh, the longest length of the subarray which is non-decreasing. Okay, we have to find out the longest subarray which is non-decreasing, and the sum of the subarray is divisible by k. So the sum should be divisible by k. And what is the meaning of subarray? So a subarray is a contiguous segment of an array. So we can see that subarray is a contiguous segment. A subarray is non-decreasing if all the elements in the subarray are in non-decreasing order. So basically we have to find out the subarray that is sorted, that is in ascending order, right? And more formally, a subarray array of I comma j is non-decreasing if the values are like this: array of I is lesser than equals to array of I plus 1, and array of I plus 1 is greater than equals to array of I, right? So this is the definition of non-decreasing subarray. So this is the problem statement. So now let us have a look on the example test cases to gain the more clarity on the problem. Okay, so this is the example number 1, that is n is equals to 4. It means that we will be given an array of size 4, and the array is ARR, and the elements are 1, 2, 3, 8. And we are also given value k is equals to 3. So we have to find out the length of the longest subarray, which is in increasing order, and the sum is divisible by k, right? So we can see that this subarray that is starting from the first element and ending at the third element, that is 1 2 3, right? So here the sum is 6, and we can see that 6 is divisible by 3, because 6 modulo 3 gives us remainder as 0. So that's why it is a valid subarray. The the elements are in increasing order. We can see that 1 is lesser, and 1 is lesser than 2, and 2 is lesser than 3. That's why it is also in increasing order like this, right? So that's why our answer for this example number 1 is 3. We can see the explanation part also. The longest non-decreasing subarray is 1 2 3, whose sum is 6, which is divisible by 3, right? So let us have a look on the brute force solution first. Okay, so what can be the brute force solution? So the brute force solution is that we can generate all the possible subarrays, and for all the possible subarrays, we will have a check that if that particular subarray that is starting from, we can say that that is starting from I comma j, and if that subarray is non-decreasing, it means that in increasing order, then we will just simply uh, mark as that this is in sorted order. And the second condition that we have to check is that the sum part, that is sum should be divisible by k. So we will generate all the possible subarrays, and for all the subarrays I will find out these two conditions, right? And so this is the brute force solution. So what would be the time complexity here? So the time complexity would be very high, and which will lead to TLE, because the constraints are like, I guess, yeah, the constraints are uh, 1 is lesser than n, and 10 to the power 6, right? So the constraints are 10 to the power 6. So we will have to think about some linear solution here. Okay, right. So let us have a look on the optimized solution. So what we will be using prefix sum and hash maps for our optimized solution. This problem is kind of similar to find the length of the longest subarray, which is divisible by k. But here we have some extra condition, that is it should be in non-decreasing order, right? So we will be doing this problem in that way, right? So how we are going to proceed? So we will be maintaining one prefix sum modulo, and we will be maintaining one variable. uh, what this variable will be storing? So it will be storing the prefix sum modulo of our array. So what is this prefix sum modulo? So as we have given k value, so at every index it will add that particular element and do the modulo of that sum variable with my k, right? So we will be maintaining one prefix sum modulo, and we will be also maintaining one map data structure. So why we are going to maintain map data structure? Because we will have to see if we have seen that particular remainder or that particular modulo before that particular index, right? So basically uh, we don't have to keep the track of the sum, we just have to keep the remainder track, right? So we just have to keep the remainder track. For example, if k is equals to 3, then I will maintain the track of the remainder, that is 1 and 0 and 2, right? So if I try to divide any element by 3, then I will be only getting these three remainders. Uh, I will get 0 if that particular element is completely divisible, and I will get 1 if it is not divisible, and also 2, right? So we will just have to keep the track of all the remainders that we are getting. That will help us to find out the subarray. If we have seen the same remainder previously, then we can say that from that element to the current index, I am having the same modulo, right? So what is the second thing? So the second thing we will be. Okay, so we will be keeping the track of the remainder in our hash map that we have seen till that index, right? So let us have a look on the example how we are going to proceed. So here is the example, that is 1238, and we are currently at index 0, right? So we will be maintaining one sum variable. That sum is the prefix modulo sum, and the k here is 3. It means that the sum will be divisible. The sum should be divisible by 3. So basically, we are at index 0. So what will be the sum at index 0? So I will add 1 to my sum variable. So sum variable is initialized with 0. So 0 plus 1 will become 1, right? So after trying to find out the modulo of 1 with 3, so it will be same. Right. Now, I will try to find out if I have seen this same remainder or same sum in my map previously or not. Why we are trying to do? Because if I have seen this sum previously, then we can just extend that previous subarray till this current subarray, so that it will be following the same condition that we have seen, right? So we are at index 0. Also, we will be putting this sum variable into my map data structure, and we can see that we have not seen this sum in my map because my map is empty. So we will just putting that 1 in my map data structure. So 1, and what is the index at which I am? So I am at index 0, so 1 as a key, and what is the value? So 0 is the value, right? Now we have moved to the next index, that is index number 1. Also, we will have to keep the array as sorted. So that's why if I have if this current value is lesser than the previous value, that is if 2 is lesser than 1, so I have to reset my sum variable, right? Why we have to reset? Because I have to find out the non-decreasing subarray. So what is non-decreasing? So non-decreasing means increasing. So the previous value should be lesser than or uh, equals to this current value, right? So we are at index 1. We can see that this current value 2 is greater than or equals to the previous value, that is 1, right? So we will be keeping this value. So that's why our sum will become 3, because previously my sum was 1 and my sum has become 3. So 3 modulo 3 will become 0, right? So if at any index my sum becomes 0, then I can just simply say that from that I have find out one subarray with sum 0, right? Not sum 0, with sum divisible by k. So we will be also keeping one answer variable, and answer will be storing the size of the longest length subarray, which is following these two conditions, that is it is in increasing order and the sum is also divisible by k. So whenever I have got my sum value as 0, so I can just simply say that so I will be updating my answer variable with the size of that subarray. So what is the size? So the size is 2. Okay. So till index 2, I have got a size of the longest subarray as 2, which is following these two conditions. That is the sum is divisible by k and also it is in increasing order, right? And also I will put that into my map data structure. So I will put 0 and what is the index? So the index is 1, right? Now I am at index number 2. I will check that if this current value is greater than the previous value. Yes, it is greater than or equals to the previous value. That's why I will not reset the value of my sum variable, right? Because if it was lesser, then I have to reset my sum variable value. So the sum variable value will remain same, that is 0. So now try to add 0 plus 3. So it will be 3. And let's try to take the modulo. So the modulo will again come out to be 0. So the sum will be 3 and the modulo will come out to be 0, right? So as we can see that the modulo is coming out to be 0, then it is following this divisibility property, and also the subarray is in increasing order. So we can say that I have got another subarray which is following these two conditions, that is in increasing order and also the sum is divisible. So what is the new answer variable will be storing? So it will be storing the new subarray length, that is 3. So our answer will become 3. And now let's try to move to the next index. So we are also we just have to again update the value of this. Okay, so we don't have to update. Why we don't have to update? Because we will be we will have to find the longest subarray. So we are just storing the very first occurrence of each remainder. So if I try to update this, so I will be getting the shortest subarray, but I am just storing the very first occurrence. So that's why I am not updating the value of this remainder and its corresponding index, right? So we are at index number 3. So what is the first condition? So the first condition is to check that if this current value is greater than or equals to this previous value or not. So we can see that 8 is greater than or equals to 3. That's why I will continue. So I will add that 8 into my sum variable. So it will become 8 and 8 modulo 3. So it will become 2. So I will try to find out if I have seen this 2 in my map or not. So we can see that I have not seen this 2 in my map. So there is no subarray which can be extended to make these two conditions satisfy, right? So in the end I will just put that 2 into my map data structure, and what is the index? So the index is 3, right? So now I have finished my array. So when we are done with this iteration on the array, and in the end we can just simply return our answer variable that will be storing the length of the longest subarray which is following these two conditions, right? So how we can code this up? So let us try to see how we can code this up. So we will be maintaining sum is equals to 0 and also answer is equals to 0. These are the two variables that we are going to maintain, and we will be also having one map data structure, right? So this is my map, and iterate on this array from 0 to n, right? And in the very first thing, what we have to do, we just have to check if I is 0 or array of I is greater than or equals to the previous value. So the previous value will be array of I minus 1. So if array of I is greater than or equals to the previous value, then we can continue. Else I have to reset the value of my sum variable, right? So how we can continue? We can just simply add that array of I into my sum. So sum plus equals to array of I. I'm just adding array of I into my sum. And if this sum variable is not present in my map, so how can I find out? So I can just simply do mp dot count of sum equals to 0. If it is not present, then only I have to put that sum into my map data structure, because I am storing the very first occurrence of every remainder, right? So just store means map of sum. Map of sum will be the index. So index is I. Also, I have to do the modulo here again. So after this adding, so I have to do sum modulo equals to k. Okay. So I will try to put that sum variable into my map data structure and also its corresponding index. Else, what I have to do, I will just reset the values. So how can I reset the values? So I will just erase all the values that was present in my map, right? Also, I will just update the value of my sum variable also, because this current variable is lesser, so it means that from this variable my new subarray will start. So that's why sum will be array of I, and I will put that sum into my array into my map data structure also. So map of sum is equals to I, right? So after this I will try to find out if let's say what is the required sum. So how to find out the required sum? So it will be sum modulo k. So I will try to find out if I have seen the same variable or the same value in my data structure, that is map or not. So if this required value comes out to be 0, it means that I have got one new subarray. So I will just update the value here. Else, if I have if this require variable is present in my map data structure, so if map dot count of require equals to 1, it means that I can extend that previous subarray with this subarray, right? So how to find out the previous subarray index? So previous subarray index will be map of rec, and what is the current subarray index? So it is I. So this will be the length of this subarray that I will be getting. So this is the length, and I will just find out which is the maximums of answer and this length, right? So answer is equals to maximum of, it will be maximum of these two variables, right? Else if it is not present, then simply put that sum into my data structure, that is map. So map of sum is equals to I, right? So this was the like pseudocode type thing, and in the end just simply do return answer. So let us try to implement this, right? So the very first thing that we will be having is my answer variable. So answer will be storing as 0, and I will also have an unordered map, that is my hash map, right? And I will be storing the key value pairs, and also keep the sum variable as 0, and one s is equals to 0, right? Now iterate on the given array. So if I is equals to 0, I less than n, I plus plus, right? So if this is the very first element, then I can just simply skip this element. Or if array of I is greater than equals to array of I minus 1, it means that the current variable or the current value is greater than equals to the previous value. It means that it is in increasing order. So just simply do sum plus array of I, and after this step just do modulo of this sum with k. And if mp.count, if this sum is not present in my map data structure, then just simply put that sum into my map data structure, and I am at index I, so map of sum is equals to I, right? Now in the else part, if the current value is lesser, then I have to just reset all the values, right? How can I reset the value? So map dot clear. So I will just erase all the previous indexes, because my new subarray will be starting from this current index, that is I, and sum will be starting from this current index, that is array of I, and also put this sum into my map data structure, and also s will become equals to I, right? After this I will find out what is the required sum. So how can I find out? So I will do just simple sum modulo k, and if value of rec comes out to be 0, it means that the subarray which is starting from the index s, and ending at index I, having is in increasing order and having the sum divisible by k. So thus do answer is equals to maximum of answer and I minus s, and also add a plus 1 because of the zero base indexing, right? Okay, so if this required, if mp dot count, if this is already present in my map, then what can I do? I can just simply extend that previous subarray. So how to find out the length of that previous subarray? So it the index will be map of require of I, map of require. So that will be the index of this previous. So what is the length? So it will be I minus map of rect. So it will be the length of the resultant subarray, and I have to find out the maximum answer. So answer is equals to max of answer and this current length subarray, right? Else if it is not present, just simply put that in my data structure, and in the end just do return answer, right? So let's try to submit. Okay, so it's getting passed on the visible test cases. Now let's try to submit on the hidden test cases also. Okay, so we are having some error here. So let's see. Okay, so at line I have to put remaining require in my map, right? So let's try to submit this after making some changes, right? Okay, so it's getting passed on this hidden test cases also. So let's try to discuss the time complexity and the space complexity. Okay, so we can see that we are iterating on our array by one. So the time complexity would be big of n, right? And inside this, we are just doing some constant operations, right? And what is the time space complexity? So the space complexity would be also big of n, because at first I will be storing all the values, so it can be big of n. Instead of big of n, it can be like big of k, right? Because we are just storing uh, every remainder, so the remainders will be from 0 to k, right? So the space complexity would be big of k, and the time complexity would be big of n, right? Now let's try to move to the next question. Okay, so the next problem name is longest common palindromic substring. So let us have a look on the problem statement. So Geek has two strings str1 and str2 containing lowercase English alphabets. Okay, so Geek has two strings and it is containing lowercase alphabets. He's trying to find the length of the longest common palindromic substring in both the strings, right? So we have to find out the length of the longest common palindromic substring, and that common substring should be in both. Help him to find the length of the longest common palindromic substring. Okay, so we have to find out the length of the longest common palindromic substring. So let's see the example number one. Okay, so the example number one is this, and we are given str1 as geek and the string 2 is geeks. So the longest common palindromic substring is EE. So we can see that EE is palindromic, and also it is present in my string 1 and also it is present in my string 2, right? So this is the longest palindromic substring for the example number 1. So this is the example number 2. So we can see that these strings are equal. So the longest common palindromic substring is ABCBA. So ABCBA is palindromic, and also they are common in both string 1 and string 2. So that's why the answer coming out here is 5. So I hope this example is clear to you. So let us see about the solution part. Okay, so we will be maintaining one DP array. So what is this DP array will be storing? So it is of size n cross n. So n is the size of my string one, and it is of size n cross n. So it will be storing the values that if that substring that is starting from my particular index, that is I, and ending at particular index, that is j. So it will be storing that if dp of I comma j is true, it means that substring from I to j is palindromic, right? So we will be storing these values in my dp array, and so we will start from I is equals to 0 and j is equals to 0, right? So we can see that single element is always palindrome. So we will mark that 0 comma 0 as true. It means that I will mark it as 1, that this substring that is starting from 0 to 0 is palindrome, right? Now for every value of I will try to decrease the value of j. So now at the next iteration the j value will become -1. So this value of j is invalid, so we will move to the next iteration of I. So I will become 1. Okay, j will be starting from the same value, that is I, and we can see that I value and j value is equal. It means that this substring will always be palindromic, so we can mark 1 comma 1 as also 1. It means that substring that is starting from I is equals to 1 and ending at j is equals to 1 is palindromic, right? So let's try to decrease the value of j. So j value will become 0. Okay, so we can see that g and E. So str of j, that is g, and str of I, that is e, is not equals. So we can see that this uh, this substring, or the substring that is starting from j and ending at I is not palindromic because they are not equal. So we will mark 1 comma 0 as false. It means that substring that is starting from 1 and ending at 0 is 0 comma 1. I will mark 0 comma 1 as false. Okay, so mark 0 comma 1 as false. Okay, now at next iteration, the value of j will become -1. Then we can see that the value of j becomes invalid. So move to the next iteration of I. So I becomes as 2 and j also becomes as 2. So mark 2 comma 2 as 1 means that string is already palindromic. Okay, and now at the next iteration, the value of j becomes 1. So we can see that I is equals to 2 and j is equals to 1. So we can see that E is palindromic, right? So we will mark 2 comma 1 as true. Okay. So not 2 comma 1, 1 comma 2. Okay, so 1 comma 2 as true. That means that substring that is starting from index 1 and ending at index 2 is palindromic. Okay, so I have marked 1 comma 2 as 1. Okay, so also we will be keeping the track of all the palindromic substring into some set data structure, right? So what was the first substring? So the first substring was G, the second was E, and the third one is EE, right? So these are the substrings that I have encountered till index 2 and they are palindromic, right? So now let's move to the value j is equals to 0. So at j is equals to 0, we can see that uh, G, E, E. So I am at I as 2 and G as 0, J as 0. We can see that G and E are not equal. So we will not mark 0 comma 2 as our palindromic. So 0 comma 2 will be marked as false. Okay. Now at the next iteration, the value of J will become -1. That is invalid. Right. So now let's move to the next iteration of I. So I will become 3 and j will also become 3. So mark 3 comma 3 as visited, not visited as true. So I marked 3 comma 3 as true also. So we can see that single element is always palindromic. So move to the next iteration of j. So the j becomes 2. So we can see that k is not equals to e. That's why we will not move further for this value of j. And again j value becomes 1. So we can see that j is not equals to k. So we will not move to the further. And again j value becomes 0. So we will not move further because g is not equals to k, and after that j value becomes -1. So the value of j becomes invalid. So we will not we will move to the next iteration of I. So we can see that at I is equals to 4, the I have utilized all the characters of that substring, not substring, that string number 1. So I will stop iterating on that array, right? So now I have got one set. So what is this set? Also, I forgot to add k here also because k is also palindromic, right? So for I value is equals to 3, I also had to add k in my set. Okay, so I have added k in my set data structure, right? So we can see that this is my set data structure, right? So what does it contain? So it contains all the palindromic substrings of str1, right? So I have got all the palindromic substrings of str1. Now I have to find out the common substrings that are equals to these palindromic substrings, right? Because I can see that they are palindromic. So if I find out any other substring that is equals to this palindromic substring, that I can also say that that substring will also be palindromic, right? Because it is equals to this substring that is palindromic, right? So now our question boils down to finding out the substring that matches up to these patterns. So we can see that I have these four substrings. So I have G, I have E, I have double E, okay, and then I have K. So I have to find out if my if my string two, if my string two contains these as a substring or not. So how can I find out? So basically, we can we can move to every every string of my set and then just do a brute force approach, like try to find out the pattern. This pattern, what is this? So the pattern that I am getting, so if I am able to find out the pattern, this string in my substring, then I will just update the value of my answer variable, right? So what will be the answer variable? So it will be storing the maximum length, because we have to find out the longest common palindromic substring, right? So I am maintaining one answer variable which will be storing the maximum length of the palindromic substring that I have got in both string 1 and string 2, right? So what I will do here, so I will iterate on every substring of that data structure that I have stored. Now, for example, for G, so I have string 2 as geeks, right? So I will find out if this string 2 has this same pattern G in my substring or in my string or not, right? So how can I find out? I will just simply do a brute force that I will try to find out what is the first character, and if I am able to find out the same pattern in my string 2 or not, then I can say that I have got this pattern in my string 2. Okay. So similarly for E, I will find out uh, what is the first index that is equals to this. So if it is equal, then try to find out the other characters. And similarly for double E, so we can see that double E is the maximum answer. So for the answer for this example, my answer would be 2. So I will iterate for every pattern and try to find out if this pattern exists in my string 2 or not, right? So let's try to see how we can code this up. Okay, so first thing is that we have to find out the size of my string 1. So integer n is equals to str1 dot size. And after that, I have to make one 2D array of vector bool, and it will be my DP array, right? So it will be of size n, and vector of bool and n, and initially mark all the values as false. It means that all the values are not palindromic, right? So iterate on I is equals to 0 and I is less than n and I plus plus. And after that, inside this for loop, I will have my j loop which will be starting from I, and it will be greater than equals to 0 and do j minus minus, right? So if str of I is equals to str of j, then only I will check for the elements between I and j, right? So if it is equal, so now let's check if I minus j is lesser than or equals to 2. So why we are taking this thing? So if we only have a single element or lesser than two elements, right? So if we only have these two elements, that is str of I and str of j, or I have the lesser elements, that is only one element, then I can just simply say that these two elements are palindromic, or this single element is palindromic, right? Also, if dp of j plus 1 and I comma minus 1, so if dp of j plus 1 or I comma minus 1 is also true, then also I can say that this substring that is from I comma j is palindromic. So just do dp of j comma I as true. Mark this as true. And also we also have to make one data structure, that is my unordered set, and what it will be storing. So it will be storing the strings. So let's name it as st, and st dot insert. So what was the substring? So the substring was starting from j, and what was the endpoint? So how many elements I have to take from j? So I have to take I minus j plus 1 elements, or the characters from this current j index. So I will just simply insert this. So I have to put this as a str1 dot substring. Okay. So, and yeah. So I am just pushing all the palindromic substring that I can make from my string 1 into my set data structure, right? Now I will make one answer variable which will be storing the length of the longest common palindromic substring, right? So iterate on my data structure of set. So string and pat. So I will get the pattern and iterate on my set data structure. Now, what is the length of my pattern? So it will be like L is equals to pat dot size, and I have to find out if this similar pattern is present in my string 2 or not. How can I find out? So I will run a for loop from 0 to lesser than equals to str2 dot size minus L, that is the pattern length, and I plus plus. Okay. So how to find out the substring? So substring, it will be let's say s is equals to it will be str2 dot substring, and it will be starting from I, and how many elements I have to take? So I have to take L elements from this I. So if this S come out to be equal to this pattern, it means that this pattern is present in my string 2 as a substring, right? So in that case, I will just replace the value of my answer. So answer will become answer max of answer, and the current length of the pattern, so it will be L, right? Also break if I have got this pattern, and in the end just simply return the answer variable. So yes, this is the code. So let's try to compile and run. Okay, so we are getting some errors. So okay, so at line 17 it should be str of 1 because we are talking about the string 1, right? And here it should be also str of 1. Let's try to compile and run it again. Okay, so it's passing on the visible test cases. So let's try to submit. Okay, so it is also passing on the hidden test cases, right? So let's move to the next problem. Okay, so the fourth problem name is longest non-decreasing subarray 2. Okay, so this is the follow-up question for the longest non-decreasing subarray 1, and we have to update the values here, right? So let us try to read the problem statement. You have been given array ARR of length n. Okay, so we are given an array and its length is n. There is a 2D array queries of size m. Okay, so we are also given one 2D array and we are also given a 2D array queries and whose size is m. Okay, so the queries are of two types. So we have two types of queries. So the first query is that 0 comma l comma r. So what is the meaning of this query? So we have to find the length of the longest non-decreasing subarray in the range from L to R, right? So this is the first query. So let's see the second query. So the second query is 1 comma I comma x, right? So this second query is the update query. So we have to update the value of array of I to x, right? So we have to perform the queries and return the answer for the queries of type 1. Okay, so we have to return some vector or the answer for each query, right? So let us see the example number one. Okay, so we are given as n is equals to 5 and array is 1, 2, 3, 2, 1. So this is the array and this is the size, and we are also given one queries array that is of size 3. So queries is of size 3. We can see that we have this is first, this is second, and this is third element of my queries array, right? So let us try to see the first query. So we can see that query first is of type 1 because the very first value is 0. So if the very first value, that is queries of 0, is 0, it means that it is of type 1 query. So we are given 0 comma 4. It means that we have to find out the length of the longest subarray that is increasing and also the sum is decreasing, right? Okay, so from in the range 0 to 4, I have to find out the length of the longest non-decreasing subarray. So we can see that for the first query, the length of the longest non-decreasing subarray is 1, 2, 3, right? And now let's see what is the query number 2. So we can see that query 2 is 1 comma 3 comma 4. Here the first value is 1. It means that this query is of type 1. So here we have to update the value which is present at index 3. So the value present at index 3 is 2. So we have to update this value. So after updating, my array will become like this: 1, 2, 3, 4, 1. So we have updated the value that was present at index 3. So previously it was 2. Now I have the updated value as 4. Okay. So after this, I have to again process the query number 3. So what is the query number 3? So it is again 0 and 4. So it means that I have to find out the length of the longest non-decreasing subarray in the range 0 to 4. So we can see that uh, I will be having 1, 2, 3, 4 as the longest subarray with non-decreasing. Okay, so that's why our answer will be 3. So for the first query, my answer is 3 because 1, 2, 3 was the length of the longest non-decreasing subarray, and the second query answer is 4 because 1, 2, 3, 4 was the uh, subarray and its length is 4. So that's why we have to return 3 comma 4 here. Basically, by seeing the range queries and update queries, we can identify that this problem will be solved by segment trees. So the prerequisite here would be segment trees. So if you know segment trees, then you can easily solve this problem because it is a small variation of our segment tree, and we can observe that if we are given some range queries and we are given some update queries, then segment tree is the best data structure to find the efficiently or do the changes or do the update in efficient manner, right? So we will be firstly defining some structure and node. So we will be having four variables. So what are these four variables? So the four variables, the first variable is left len. So what does this left len will be storing? So it will be storing the length of the longest non-decreasing subarray that is starting from leftmost element of that particular segment. Okay, so this is the left len variable will be storing. So let's see what is the right len variable will be storing. So it will be storing the length of the longest non-decreasing subarray ending at rightmost element of that particular segment. Okay. Now the third value will be total length. So what is the total length? So it will be the total length of that particular segment. And in the end, I will be storing the max length. So max length will be the length of the longest subarray within the particular segment. Okay. So I will be storing these four variables and I will try to build a segment tree using this node. Okay. So if you try to see the example number one that we have taken, so our build tree will be looking like this. So let us see how we are implementing this build function. So first of all, we will go to the function that we are going. Okay, so at line 179, we have the longest subarray function, and this is the function that we have to return to our main function. So we have integer n. So what is n? N will be the size of my array, and we have vector integer array. So this will be containing. It will contain the value of my array, and after that I have the integer m. So it is the size of that query array, and after that I am getting my queries array that is of size m. And at line 181 I am getting the result vector array that I have made some another function longest subarray, and I have some another parameter that I am passing in that longest subarray function, and I am passing my array, and then I am passing my queries array and the size of my queries array, and in the end just simply return the result and result vector. Now let us see how we are implementing our longest subarray function. So we are receiving the integer array and then queries array and then the size. After that at line 64, we are making an object of our segment tree class. Okay, so this is our segment tree class. So uh, at line 164, we have made our segment tree class object segtree, and we are passing our integer array that we have got from the main function, and by this segment tree object we will see how we are making our segment tree, right? And after that at line 165 I will be storing our result in this vector integer result. And so let us first see how we are implementing our segment tree class, right? So this is our segment tree class, and at line 52 we have discussed that we will be storing node value, and we have talked about like left len, right len, total len, and max len, and left value. So what will be the left value? So the left value will be the value of its left child. And what will be the right value? So the right value will be the value of its right child. Okay. So we are initializing them by 0, and let us see how we are defining our class segment tree. Okay, so at line 60 we will be storing, we will be making our vector of node, and we will be naming it as tree, right? And we have to store node type in our vector, so that's why we are taking vector of node. And after that we are taking integer array. So this integer array will be storing the values that will be the values that we are being passed into our main function, right? And after that we have some integer n. So this integer n is the size of my integer array that have been passed into my function, right? So we will see this merge function later on. So the first thing that we have to say is this constructor part, right? So at line 143 I have my constructor. So we have made our object for this segmentary class, and we are passing our array in this constructor. So we will be receiving that input, that in my input array, right? Because we are passing it at line 164 here. We are passing this array into my line 164. So we will be receiving that at line 143. And what we are doing here, so we are just resizing our uh, tree tree vector by 4 into n, and then just doing build. Okay, so we are calling our build function. So let us see how we have implemented our build function. So the prerequisite here is that you know what are segment trees and how do we build a segment tree, right? Okay, so this is our build function, and we have the integer idx. So the idx, and we have integer low and integer high, right? So what is the very first case? So if low is equals to high, it means that I have only one node. Okay, so if I have only one node, then what will be the left length of that particular node? What will be the right length? And what will be the total length? And what will be the max length, right? These all four values will be one for that particular node. So left length will be one, right length will be one, total length will be one, and also the max length will be one for that particular node, because it is the single node. When the low value becomes high, it is becomes single node, right? And what will be the left value? So left value will become the value of that array of low. So if uh, array of low and array of high are similar, so we can take any of the value. And also what will be the right value? So the right value will also be array of low, right? So this is the case when we only have only single node. So if we have multiple nodes, then what we do, we generally find out the mid value. So we are just finding the same. So it is kind of similar to that we have discussed earlier in our segment tree. Okay, so integer mid is equals to low plus high by 2. So we are just finding out the mid value and just call recursively on the left side. So how to find out the left side? So the left side will be 2 into idx plus 1. So if we are at idx, so the left child will be at index 2 into idx plus 1, right? And at the right side, the right child will be at 2 into idx plus 2. Okay, so we are calling the recursion on its left side. So this is on the left side, and the second recursion is on the right side. Okay. Also, we are just changing the values of low and high for these values. So for the left child, my low will remain same, but the value of high is now mid, because we had calculated this mid value. So for the left child, uh, my high will become this low, and this my high will become this mid, and low will remain the same. And for the right side, my low will become mid plus 1. So this is mid plus 1 and high will remain same, right? So that's why we are passing mid plus 1 and high into our right recursion call. Okay, so after these recursion calls are finished, so we have to merge left these two childs, right? So if we have called them recursively, so it means that they will be built recursively. And after we have built the left child and the right child, so we have to merge them into our to make a particular node, right? So if the left child is being made and the right child is being made, so we have to merge them, and that's why we are calling our merge function. So merge tree of 2 into idx plus 1. So this is the left child tree of 2 into idx plus 1, and this is the right child, right? So that's why we are merging two childs. So let us see how our merge function is being implemented, right? Okay, so we have our merge function here, and what is the return type? So it will return a parent node. So we are receiving this left node and we are receiving this right node, right? So as we have discussed in our build function, so we will build two nodes, that is the left node and the right node. Now I have to merge them into my parent node. So that's why we have written some other function, that is my merge function, and we are receiving left node and right node. Okay. So what is the very first value? So the very first thing is that I have defined a node parent. So this is the parent node, and in the end I am going to return this parent node. And what is the total length of my parent node? So the total length of my parent node would be the total length of this left node. So how we are calculating this? So we are just calculating left node dot total length. So this will give the total length of my left node, and how to get the total length of its right node. So do just right node dot total length. So this will return the total length of its right node, and just add them to find out the total length of its parent node. Now, what will be the parent's left value? So what is the left value? So the left value is the leftmost value of my particular segment, right? So the parent's left value will also become the left node's left value, right? Also, what will be the parent's rightmost value? So the parent's rightmost value will becomes its right child's right child's rightmost value, right? So basically, for example, this is my parent, and let's say this is my left subarray, and this is my right subarray, and basically this is a node, right? So this is the left node's leftmost value, and this is the right node rightmost value, right? So if I am going to combine them, so for this, what will be the leftmost value? So it will be the leftmost value of my left child. And what will be the rightmost value? So it will be the rightmost value of my right child. So we are doing the same here. So in these two lines we are just finding out what will be the left value and what will be the right value, right? Okay, so now let's move to the next part. Okay, so the next part is compute left length. So we are just computing the left length here. So we are just using some if condition. So if left node left length is equals to left node total length. So what is the meaning of this? So if the entire left subarray is non-decreasing subarray, that is left node dot left length is equals to left node dot total length, and the last element of the left subarray. So this thing left node dot right value. So if the last element of the left subarray is less than or equals to the first element of the right subarray. So what is the first element of the right subarray? So it will be the leftmost value of the right node. Okay, so this is the first value of the right subarray. So basically we are talking like this. So suppose this is my subarray. So this is the uh, leftmost value of my right subarray, and what about this? So it is the rightmost value of my left subarray, like this thing. So if this is lesser than or equals to this rightmost left value, then we can just combine them, right? Because we have to find out the length of the longest increasing subarray. So if the left subarray is already in increasing order and the right subarray is already in increasing order, and the values of the rightmost value of my left child and the leftmost value of my right child uh, is are also becoming in increasing order, so we just merge them. Okay, so that's why we are just merging them. So parent dot left length is equals to left node dot left length plus right node dot right length. Okay, uh, right node dot left length. Okay, so we are just merging them. So yeah, so if it is not equal means that uh, if that we cannot extend our subarray, so the left subarray's left length will remains unchanged, because we cannot extend that particular subarray, so that's why it is remaining unchanged. So that's why parent dot left length is equals to left node dot left length, so it remains unchanged, right? Similarly we will compute the right length with the same logic. Okay, so we can see that we are just doing the same thing here. Right node dot right length is equals to right node dot total length. It means that the entire right subarray is a non-decreasing subarray, and also left node right value, as we have discussed earlier also. So leftmost right value and the right node left value like this. So it is lesser than or equals to, then it means that we can extend this subarray to make a new subarray with increased size. So that's why parent dot right length becomes the left node right length, and right node right length sum. Okay, and if it is not, then the right subarray's right length remains unchanged. Okay, so here uh, it is remaining unchanged, right? So how do we find out the max length? So we have discussed about the parent's left length, and we have discussed about the parent's right length. So how to find out the parent's max length? So firstly, we compare the max length of the left and right subarray and take the maximum of two. So here we are just comparing the left node maximum length and right node maximum length, and we are just finding out the maximum both of them, right? Now we are just checking if left node right value. So we are discussing this again. So if leftmost right value, leftmost rightmost value, and the right node's leftmost value, so if they are like less than or equals to, then we can extend the, we can say that this whole will be the new subarray. So that's why parents dot max length will be the parent dot max length, comma, left node's right length and right node's left length. So it will be maximum from these two values. So whichever is maximum, it will be stored in parent's maximum length. And in the end, we are just returning our parent node, and it means that we have merged our left node and the right node, and this is the parent node that we are just returning here. Okay, so I have this merge function is also clear. And now let's see about the other functions of the segment tree class. Okay, so we have discussed about the merge function. We have also discussed about the build function. Okay, so we are going to discuss about the update function, right? So update function is also similar that we generally do or like generally create in our segment tree class. Okay, so we can see that this is my update function, and what is this IDX? This IDX is the node and at which we are currently, and we will have the low pointer and we will have the high pointer, and we are also having position and value because we have to update our array. So we have to update the uh, array and the value which is present at array of position, right? So we have to update the values. So if low is equals to high, it means that there is only one node. So we just have to it means that we have got our node, so we will just replacing the values. So that's why array of pos becomes value. It means that we have replaced the value of array of pos, and what will be the tree's left length and tree's right length and tree's total length. So it will be 1 because we have made our new node. And what will be the left value and what will be the right value? So it will be the value that we are just receiving from that particular function in our update function, right? Okay, so if this is the case, it means that I have got that node and just simply replace the values and return after that. Okay, so if it is not the case, so we will just find out where we have to update. So how we will find out? So we will just finding out the mid value. So mid will come out to be low plus high by 2, and if position is lesser than or equals to mid, it means that something like this. So this is the mid value. If position is lesser, then it means that it will be in this search space. Okay, so in this space. So that's why we are just calling our update function on our low and mid. Okay, and what will be the leftmost child value? So the leftmost child value will become 2 into index plus 1, right? So position remains same, value remains same. Only the thing that we are changing here is the value of I, because the position will be present in the left part. Similarly, if position is greater than mid, then it means that it is present on the right part. So we are just calling our update function on its rightmost side, that is 2 into index plus 2, and we are just changing the mid value, low value here. So low becomes mid plus 1 and high remains the same, and also the position remains same and the value remains same, right? So after calling this update function, so we have to merge our tree again. So let's say this is the left side and this is the right side. So after calling, so we have to merge them. So we are just calling our merge function again. So this is the left side, that is 2 into idx plus 1, that is left side. And what is the right side? So the right side is 2 into index plus 2. So this is right side. So we are just merging them. Okay, so we are just merging them, right? So this was the update function. Now let's talk about some other functions. Okay, so the last function is query function, right? So let us see how we are querying our segment tree from the range L to R. Okay, so we have this query function. So what this function will return? It will return the node that is having the longest non-decreasing subarray in the range L to R, right? Query the segment tree to find the longest non-decreasing subarray in the range L to R. Okay, so we are getting index, we are getting low, we are getting high, and we are getting also L or R. So what is the L or and L and R? So these are the range in which I have to return the maximum. I have to return the node, okay, which is having the value of the longest non-decreasing subarray in that particular range. Okay, so if low is greater than R, it means that uh, we are not in that particular range. Suppose low is here and R is very lesser than low, it means that uh, it is not in our range. Also, if high is lesser than L, it means that it also means that we are not in the range. So what to do in that case? So we are just making empty node, and the left value and the right value will be integer minimum, and just simply return that empty node, stating that it is out of range. Okay, and if the node is fully in range, so how do we check? So if low is greater than equals to L, it means that it is greater than equals to L, and if it is high, if high is lesser than equals to R, it means that the range is something like this. So if we have low here and high here, so if it is low and if it is high, so our range is between them. Okay, so if it is between them, then just simply return the node at index. So we are just simply returning tree of idx, right? If it is not the case, then what we are doing here, so we can see that we are just simply finding out the mid value. So how do we are finding the mid value? So how do we are finding the mid value? So the mid value is low plus high divided by 2, right? And we are just finding out the left node. So how do we find the left node? So we are just recursively calling our query function. So the left side, we can see that 2 into index plus 1 will be the left side, and low and mid will remain this, low will remain the same, but the value of high will be changed as mid, because we are calling our query function on its left side, and the value of L and R is same, because we are querying on this L to R range. Also, we will call on its right side. So how do we call on this right side? So we can see that the right side index will be 2 into index plus 2. That's why we are passing 2 into index plus 2 in our right side function call, and the value of low will become mid plus 1 and the value of high will remain same. Okay, and what are the value of LNR? So they will also remain same, because we have to find the longest non-decreasing subarray in that particular range L to R, right? So after calling these function calls, so if the left node total length come out to be 0, it means that the left node total length is coming out to be 0, it means that there is no longest non-decreasing subarray on its left side. So we are just simply returning its right node. Okay, so if the left, there is no left, so we are just simply returning its right node. And similarly, if right's node is total length is coming out to be 0, it means that there is no longest non-decreasing subarray on its right side. So we are just simply returning left node here. Okay, so if they are, they both are non-zero, so we are just, firstly we are merging the left node and right node. So first we have to merging the left node and right node. So after merging we will get one node, that is my parent node. So just return that parent node as our answer, right? So this is our query function, right? So let's see if we have any other function left. Okay, so we have discussed about all the functions here, right? So, okay, so let us see from line number 164, because we were discussing about the segment tree object and how we are going to build. So as we have discussed that thing, now let us discuss how we will calculate the answer for that particular query, right? So we have made one object of my segment tree class and we are passing array, because we know that we have to pass this array to make our segment tree, right? So we have discussed that thing earlier. Now we are making our vector integer result. So what it will be storing? So it will be storing the result for every query which is of type 1, because we have to return the length of the longest non-decreasing subarray only when we are getting the query of type 1, right? So after that we are just iterating on our queries array, because queries array is of 2D type. So we are just iterating, and if query of 0 is coming out to be 0, it means that query is of type 1. So what was the type 1? So we just have to find out the longest non-decreasing subarray. So how we are finding out the length, how we are finding out the left and r. So l and r. So to find the l, so it will be present on query of 1, and to find out the r, so it will be present on query of 2, right? And after that we are just querying on l to r, because we can see that this query function will return the length of the longest non-decreasing subarray in that particular range, that is L2R. So we are just calling our segment trees query function, and we are just returning, we are just pushing back into our result function, right? So this query function that we are calling at line 170, so it will be at line 156, right? So this is at line 156. Now this line 156 function will call that query function that we have discussed, right? So we are just finding out the max length of that particular node. We are just not uh, we are receiving a node that will be containing some values, and one of the values is maximum length. So we are only focusing on that maximum length. So that's why we have made our some other query function that will that will return the integer part uh, of that particular node, that is my maximum length. Okay, so at line 170 we will be pushing that maximum length in our result array. Else, if the query is of type 1, it means that we have to update the value that is present on query of 1 as query of 2, right? So that's why how we are finding the index. So integer I is equals to query of 1, that will give me the index at which we have to change the value. And how to find out which value we have to change? So the value that we have to change is x is equals to query of 2. Okay, so after that we are just calling our segmentary dot update function. So let us see what is the update function. So from line 173 we will come at line 151, because this is the update function. Now in this update function we are just passing 0 0 and -1 I and x. So why we are passing these things? So we can see that initially the index is 0, and also low will become 0, and high is the rightmost pointer and low is the leftmost pointer, right? and position. So the position we are getting from that function is I, and what is the value? So the value we are getting here is x. So we can see that all these four values, right? And in the end just simply return the result. So what is the result vector? So it will be keeping the result for every query of type 1, because we have to find the length of the longest non-decreasing subarray if we get the query of type 1, right? So we have discussed all the functions of our segmentary class, and yes, the prerequisite here was the segmentary. So if you don't know segmentary, then you have first have to learn about the segmentaries, how our build function works, and how we update queries, and how do we merge the two nodes. Okay, and this was like direct segmentary problem. So let's try to compile and run this. Okay, so it's getting passed on the visible test cases. Now let's try to submit. Okay, so it is also passing on hidden test cases. So I hope you find this video helpful. Thank you.